Chapter 6, review page 4. Number 14. So they're giving us all these are parallel. So really it's almost side splitter theorem. Because these are all parallel sides, the corresponding parts are going to be in the same ratio. So I couldn't really use side splitter because I didn't have any of the numbers from this side, any of the side lengths. So I had to use the total that they gave me. So 48, and then what I used here was I took these three and added them to find the total here. So my ratio is going to have to be 48 to 60. Now, when they say this respectively, what it means in that order. So 15 goes with AG, 20 goes with GE, and 25 goes with EC. So that's what respectively means, in that order. All right, so now I'm going to set up my proportions. So I decided to put the 48 on top. So what I'm trying to do is remind myself to be consistent, always putting these on top. So I'm going 48 over 60 will equal x over 15, and then solve. So for the second one, I could start using side splitter. Really, I could do something like x over 15 equals y over 20. I'm just going to stay consistent, though, using the 48 over 60. I could do that the other way, though. So again, last one, 48 over 60 equals this time z over 25. Okay, so I've got AF is 12, FD is 16, and DB is 20. All right, on to 16. Sorry, I'll get this out of the way. Okay, so since the center of dilation is the origin, really we could multiply or divide, whichever way you decide to go, to calculate the scale factor. Now, the scale factor K, I always know as image, or the new, so 3 over the pre-image, which will be 6. That's what I'll use. And you really only have to focus on one of the variables, one of the coordinates. So I'm going to just focus on x. Now that's the image, so that should go on top, and that's the pre-image. You know, if you're ever unsure, you can look at it like, all right, did the image get closer or further? Since it got closer to the center, it should be a scale factor that's less than 1. So it's a reduction. Make sure your scale factor reflects that. So just double check. Now, same thing here. We're now going to apply a scale factor of 1/2 to create the new image. I'm sorry, the pre-image actually. So we're going to work backwards. There's two ways you could do this. You could multiply by 2 to get -4, 8. Or I chose to do it in proportions just to be consistent. But really, a scale factor of 1/2, if you're reversing it, is like multiplying by 2. Now, I'm showing the proportions. So I'm taking the scale factor 1/2 to be image over pre-image. Now think, they gave me B prime, which is the image. So for x, I put -2 up top. Cross multiply, and we'll get our pre-images for x, which is -4. Same thing for y. Okay, so B prime, the image, to B, the pre-image, should be in the ratio of 1 to 2. So I'm going to put 4 for the y value up top, and I'm going to put the missing y down there that we solved for. So that's all. So remember, it's always image over pre-image for K. Now y is 8, and we got choice 4. Okay, so last one here. When we would construct the center of dilation, all we do is we take a straight edge. I'm going way too far here. Straight edge just for the path. Now, it could go either way, so I just know that they're going to intersect over here, I can tell. But if they were going to intersect this way, it would go out that way. So the straight path can continue in either direction. Okay, so I take care of the path that B and B prime used. The center is somewhere on this straight path. So then I also use a straight edge for C and C prime and find out where those straight paths intersect. And wherever that is going to be our center of dilation. That's it.